Yeah.
All right. I think we're going to get started. We're going to mute everyone, and I'll explain that a little bit. But we've got an opening video to welcome everyone.
In 1938, Ducks Unlimited Canada began protecting and restoring Canada's wetlands. Today, our work is more critical than ever. Our science shows wetlands give us clean water, they store carbon, and they help offset the impacts of our changing climate. Protecting wetlands protects us all. Our wetlands, our future. A message from Ducks Unlimited Canada.
Well, good evening, everyone, and welcome to the second Ducks Unlimited Canada Marsh Masterclass. It's really great to see all of you. I, of course, recognize many faces and names this evening, and I see we have people from coast to coast and as far south as Louisiana, so welcome, everyone. For those of you who don't know me, my name is Cynthia Edwards, and I'm the Director of Major Gift Programs for Ducks Unlimited Canada and the Senior Development Manager cross-border. So I get to work with our wonderful partners in the DU family across Canada, the US, and Mexico. So a few housekeeping items before we get started. All of you will be on mute. We have several breaks for questions throughout this evening. So if you have questions, please use the chat box. I know many of you are now old hat at using Zoom meetings. So use the chat box and I'll prompt you to unmute yourself if you want to ask the question directly. If you want me to just read your question, please indicate that in the chat box and I will do so. Dale, can you move to the next slide?
Sure.
So thank you for taking the time to spend with us tonight. All of you, our DU Canada major donors, are a critical piece of our conservation puzzle. Your investment in DU Canada not only helps us directly, but also enables us to leverage funding from state, provincial, and federal government partners on both sides of the border, as well as our foundations and corporate partners. But it all starts with people like you who've made that investment in Ducks Unlimited Canada. Sterling Adams, the former DU Inc. president, once said, "Conservation without money is just conversation." And although we're looking forward to a great conversation tonight, we're more excited to be out in the field doing the conservation work we love and that all of you support. So on to the conversation. We are very fortunate to have DU Canada research scientist Dr. Dale Wrubleski with us this evening. Dale is actually retired from Ducks Unlimited Canada as of last week, but has graciously agreed to come back and spend some time with us. And for those of you who've been around for a while, you realize that no one ever fully retires from DU. Dale was with us for 25 years. And some of you will know him from Ducks University if you've been fortunate enough to attend that event, which in regular years is held every spring in the prairies. In addition to leading research projects, Dale has also mentored numerous students who have continued on as wetland scientists and practitioners. He has an intimate knowledge of the wonderful and historic Delta Marsh, which he's going to share with us tonight. So without further ado, I will pass it over to you, Dale.
Well, thank you, Cynthia. It's indeed a pleasure to be here this evening to talk about the Delta Marsh, a very special place for me and for many, many other people who have ever been to Delta. And I want to emphasize what Cynthia just said and talked about in terms of the passion and the hard work of many, many people and organizations who've come together to really make this project a success. It's been a long time coming, and we've all worked very hard at it, and I'm really privileged to be part of this Restoring the Tradition project at Delta Marsh. So to get started, we get going here. There we go. So just to introduce you folks who have not been there or not as familiar with where Delta Marsh actually is, this is a Landsat image of South Central Manitoba. Two cities illustrated along the bottom of the slide, the city of Winnipeg and Portage la Prairie. If we start with Winnipeg, you see that wiggly blue line coming up from the bottom of the screen, heading up north to the south end of Lake Winnipeg. And that's the Red River passing through as it gets to the lake. That's the Netley-Lebo Marsh. It's probably the largest freshwater coastal wetland in all of North America. And just to the south and west of it, and hopefully you can see my cursor, is Okamic Marsh, where our head office is based. And about 1 hour's drive straight west of that is Delta Marsh, situated along the south end of Lake Manitoba. And this is the area here. Now, I mentioned Winnipeg. Just to the west of that is Portage la Prairie, and that wiggly blue line going through Portage and up through here and meeting up in downtown Winnipeg is the Assiniboine River. And the Assiniboine and Red River meet in downtown Winnipeg at the Forks. But you'll notice at Portage la Prairie here, the river's quite wide, and then the rest of the line going towards Winnipeg is much narrower. But you'll see this straight line that heads off to the northwest and then heads straight north into the south end of Lake Manitoba. That's the Portage Diversion, or Assiniboine River Diversion. This is an image of south central Manitoba from 2014. We were experiencing the second 1 in 300 year flood event. We had the big flood in 2011, and then we had another flood in 2014, and that's what you're seeing here illustrated in the satellite image. So what's happening here is the control structure at Portage is restricting flow downriver and diverting the flow that floodwaters north into the south end of Lake Manitoba. And what I like here, or don't like really, is you'll notice that as it gets towards the marsh, you see that the west side of the marsh is quite well flooded. That's because there's a fail-safe here that protects the outlet structure at the lake. So what's happened here is that fail-safe has failed, as it's supposed to, and the floodwaters are actually moving through the west marsh, filtering through there as they head out to Lake Manitoba. So you can see one of the major impacts to the marsh and to Lake Manitoba is this flood control structure, and sometimes has a particular significant effect on the west marsh. So we go to the next slide. This is another satellite image, but it's a much closer view of Delta Marsh. As I said, it stretches along the south end of the lake. It's about 30 kilometers from one end to the other approximately. And what separates the marsh from the lake is this narrow beach ridge. It's a forested ridge, and you can see the white line along the north side of it. That's the sand, the beach. And an important feature here are these openings in the beach ridge, which allow water to move between the marsh and the lake. Over on the far east side is Clandeboye Channel. This is the Delta Channel in the middle of the marsh. This is where the village of Delta is, and some cabin developments along here. The Delta Waterfowl Research Station is situated right here as well. Here's the Assiniboine River Diversion coming up, and that isolates the West Marsh over here, and there's two channels over on this side. This is Cram and Deep Creek. And the marsh we divide really into 3 units. As I mentioned, this is the West Marsh. It's completely isolated now from the rest of the marsh by the diversion structure. Much of the marsh on this side is privately owned by the Portage Country Club and the Lakewood Club. The University of Manitoba Field Station used to be situated right about here. To the east of the diversion and between the diversion and Highway 240, this is the highway that comes up from Portage la Prairie. This would be the spot right here is where the Delta Marsh sign would be as you're driving up towards Delta. This is the center marsh area. And then everything east of the highway going all the way up here to a control structure right here. This is Sioux Pass, the DU project to the east. But this whole area here we refer to the East Marsh. So this is areas such as many of you might know as Cadam Bay, Simpson Bay, East and West Bluebill Bay. This is Waterhen Bay and Clandeboye Bay. So the East Marsh is by far the largest section of the marsh. As I mentioned, these large bays are essentially large shallow lakes that are linked together throughout the marsh. And I mentioned that shallow, although these bays are several kilometers across, water depth on average, depending on average conditions on the lake, could be about 1 meter deep. And of course that fluctuates with what's happening on the lake. And that's important because this is, the marsh is connected to the lake, so water levels between the lake and the marsh are synchronous, but also this is a wind-driven system. Winds from the northwest blow down the lake, push water into the marsh, and then when the winds turn around from the south, it blows the water out of the marsh back out towards the lake. So if you were ever to stand on, say, the Delta Bridge, for example, 1 hour the flow might be going into the marsh, a couple hours later it might be coming out of, or going the opposite direction. So it's a wind-driven system. Water levels fluctuate continuously within the marsh, whatever, depending on the wind strength and wind direction out on Lake Manitoba. So these channels are very important. They link the marsh to the lake. They allow water exchange, as I just said, as well as nutrient sediment. And an important part of what I want to talk about this evening is the fish community that uses the marsh. Because the marsh is so shallow, much of it either freezes to the bottom. What doesn't freeze to the bottom goes anoxic. So it doesn't provide year-round fish habitat, at least for most of the species. What the fish do in the fall, and where they were this past winter, was out on Lake Manitoba. And then in the spring, as the channels open and the ice comes off the marsh, they start migrating into the marsh. When they use it for spawning, feeding habitat, rearing their young, and then late in the fall, as the marsh starts to ice up again, they all migrate back out to Lake Manitoba where they spend the winter. So while Delta Marsh is well known for waterfowl, as I'll mention in a minute, it's also an important habitat for 31 species of fish that we've documented in the marsh. And one of those species is a lot of what I want to talk about this evening as well. So why do we care about Delta, and why do so many people know a lot about Delta Marsh? That's because of the abundance of waterfowl. The image on the right here is one of many photographs you'll find of the market hunting that used to happen at Delta Marsh over 100 years ago. The locals, often in the fall, made their income harvesting the birds on the marsh because of the high densities of waterfowl, and then would sell those to the table trade or table fare in Portage and in Winnipeg. And the stories of the abundant waterfowl, and particularly the one bird that people did tend to focus on was the canvasbacks on the left side here. That's what really started to raise the profile of Delta Marsh for the abundant waterfowl that were there and the hunting opportunities they provided. And as the word got out, the rich and the famous started to come to Delta Marsh. Two future kings, the Duke of York, Prince of Wales, over 100 years ago, visited Delta Marsh to hunt. Other notables that came to Delta, Clark Gable hunted the marsh. I actually met Ted Turner. At the time, he was Mr. Jane Fonda, but the original owner, I'm not sure if he still is, of CNN News. I met him at Delta at one time. Other people who came to the marsh were very instrumental. Jimmy Robinson in the lower left was a writer for Sports Afield magazine. He actually had a lodge on the marsh, and actually the lodge is still there, still operational. But Jimmy wrote lots of stories about Delta Marsh and hunting the marsh in Sports Afield magazine, so that helped really raise the profile, as well as the artists and authors who've been through Delta. Lots of artwork that you can find, imagery of Delta Marsh. Here's one painting by David Mass. Writers, Albert Hochbaum was the first director of the Delta Waterfowl Research Station. He was the director of the station, but he was also an author and an artist as well. The book Canvasback in a Prairie Marsh is about his observations of canvasbacks at Delta. And To Ride the Wind was one of his art books that's well known, that highlights some of the artwork from the Delta Marsh area. But not just the rich and the famous. Delta was unusual in that it also had two research stations. The Delta Waterfowl Research Station has been there since 1938. It was and has been a major hub for waterfowl researchers and wetland ecologists around the world to come to Delta to learn, and that facility supported lots of students and their professors who did work on the marsh, as well as the University of Manitoba. The image on the right is the Capituan, the office for the University Field Station. Also supported lots of students, professors, lots of graduate student research on the marsh. Unfortunately, that major flood event I mentioned in 2011, the University Field Stations had a lot of damage to a lot of the buildings, lost a lot of its buildings. The university unfortunately closed the research station in 2011. The Delta Waterfowl Station had a lot of damage to its buildings as well, lost a lot of buildings actually, but it's still functional. Some of the buildings are still in operation. Kirkhofer Lodge, for example, is still there, and it actually served as the base of operations for the research and the monitoring work I'm going to talk about in a few minutes. So all of that combined really helped to raise the profile of Delta Marsh, and because of that, it's received a number of acknowledgments. In 1982, it was acknowledged as a wetland of international significance because of the abundant waterfowl populations that the marsh supports, particularly in the fall during migration. Locally, it's known as a heritage marsh through the program through the province of Manitoba. Also designated an important bird area by Bird Studies Canada, and much of the Crown land was given some protection as a wildlife management area in 2006. Unfortunately, while waterfowl hunting used to be a very important activity in the marsh, there were starting to be concerns about the condition of the marsh, the health of the marsh, particularly from the waterfowl hunting community. Starting in the late 50s, early 1960s, you know, the marsh was changing. Duck numbers were starting to decline. They weren't as abundant as they used to be, or if they came through, they didn't stay for very long. And this is just one of many reports that were filed about concerns about the health of the marsh and you know, what was going on there, and something needed to be done about Delta Marsh. What the stakeholders and the hunting community were telling us was that these were some of the changes they were seeing. Those large bays I mentioned, over time, and we go through the air photography and satellite imagery, and we've been able to document this. We've seen a real loss of the islands, the buffering capacity within those large bays to protect them from wind and wave action. And the emergent vegetation along the shoreline, we don't have a nice flooded emergent soft edge anymore. Much of the shoreline, particularly on the south side, is very much a hard edge to those bays. And along with those changes in the large bays, we've seen a decline in the submersed plants. Those plants are important for holding the sediment in place, providing food resources for birds and for fish, and supporting the invertebrates that birds and fish rely on as well. Loss of submersed vegetation means that sediments get stirred up. We're seeing an increased turbidity or cloudiness of the water column. Also, in the last many years, we're starting to see more blue-green algal blooms at Delta as well. And so that's what's happening in the big bays. And then if you look at around those big bays, the shallow ponds around the periphery that would provide habitat, say, for example, for dabbling ducks, we have an invasive cattail species which has been slowly filling in those ponds. So we've been left with these large windswept open bays and losing the shallow peripheral ponds around those big bays. And because of all those changes, we're seeing fewer muskrats on the marsh, so less trapping opportunities for local trappers, and declining waterfowl numbers and hunting opportunities for those as well. Now, there's a number of not one single factor is responsible for all the negative changes in the marsh. There are a number of things that have been identified, but this is one that we've really become interested in that was a concern back in the 60s, and efforts were made to control them then. Lots of reports in literature of other efforts to control carp populations. This is an invasive fish species that was introduced into North America in the 1880s, primarily as a food fish because of declining native fish populations due to overharvest. And if they had been left as an aquaculture in ponds, probably wouldn't have been much of an issue, but for whatever reason, either intentional or accidental introductions, these fish escaped into the wild and have pretty much spread right across North America. These are one of the most widely introduced fish species in the world, and also one of the fish species with the longest history of aquaculture. Now, I'm going to take a little sidestep here for a minute. These are common carp. I also want to mention the Asian carp, because you have been hearing a lot about them in the news. These are also fish that were intentionally brought to North America to deal with problems that they were trying to solve in the catfish aquaculture industry in the southern US. All of these fish help to alleviate certain problems related to trying to raise catfish. They're brought over from Southeast Asia. Unfortunately, during floods on the Mississippi River, these fish escaped into the river and have been spreading up through the Mississippi, the Ohio, Missouri systems, and are now right on the verge of the Great Lakes. They've made it all the way to the Chicago Shipping Canal, which is an artificial canal that connects the Mississippi River with Lake Michigan, the south end Lake Michigan. And the concern is these fish getting into the Great Lakes. So there's a concerted effort to prevent them from getting in there. There are electric fields. There's an electric fence in the bottom of the channel that stuns the fish as they try to migrate through that. And there's several sets of these as they're trying to prevent these fish from migrating and getting into the Great Lakes. One of these fish you may know a little bit about if you've ever seen YouTube videos of these jumping fish in the Mississippi River. That's the silver carp in the lower left fish. These are fish that can get 20, 30 pounds in size. And they have a defensive behavior that when a motorboat goes by, the pressure waves from the propeller scare them, thinking it's a predator. and they jump out of the water, and you can see these videos where this masses of these silver fish are jumping out of the water. And you can imagine if you're boating along and all these fish are jumping out of the water in front of you, people have been knocked unconscious, knocked out of boats by these fish as they're jumping out of the water. There's also some pretty amazing videos of people shooting them with bow and arrow as they're boating down the river as well. So these are the Asian carp, and the concern there, of course, them getting into the Great Lakes. Common carp are pretty much already spread across North America. They've been here much longer, and unfortunately, pretty much have moved right across the North America, and pretty much anywhere else they've been introduced in the world, they become an issue when they get released in the wild. These are bottom-dwelling fish. Heather's holding an example of a mirrored carp. Carp actually come in 3 varieties. There's the fully scaled version. This is a mirrored carp. You can see it doesn't have scales in part of the body, and then he's got these patches of these large scales. About 1 in 100, 150 fish we catch at Delta are these mirrored carp. Same species, just different variety and scale patterns. And then there's actually leather carp, which have no scales at all. We've never collected or caught a leather carp at Delta. We do get the odd mirrored carp, but for the most part, they're the normal scaled variety of these fish. So these are large, as you can see, bottom-dwelling fish. They're basically vacuum cleaners swimming along the bottom of the marsh, sucking up the sediments. They push their heads into the sediments, and as they're doing that, they're trying to filter out the invertebrates and other plant material in the bottom. While they do that, they, of course, stir up the sediments. They uproot the submersed vegetation. They spawn in flooded vegetation. So you'll see a large female attended by many males, and they thrash through the flooded vegetation. So these are very destructive fish, especially when you have them in very high densities with very large individuals, such as the one Heather's holding here. So wherever these fish have ended up in the wild, when they come in, and they like to spawn in wetland habitats, shallow warm water systems where they feed, where they spawn, and where the young grow up, they're very destructive to these types of habitats. So unfortunately, they arrived at Delta Marsh, Lake Manitoba, sometime in the late 40s, early 1950s, and as the locals say, by the early 60s, you could walk on the backs of common carp across Delta Marsh. So that's our first spot for a break, and I think Cynthia's gonna lead us off into some questions.
Great, thanks very much, Dale. I was just gonna kick off with, is carp the main problem driving the reduced productivity of the marsh that we've seen?
No, there's there's other factors, at least a couple of them. One is stabilized water levels. Lake Manitoba is not managed for power generation like many of the other lakes in northern Manitoba, and Lake Winnipeg is, for example, just to the east of it. It's actually managed by the province of Manitoba for the benefit of landowners around it. And that's because historically, Lake Manitoba went through very high and very low water periods. This is very flat terrain around this lake, so an increase of a foot or two in water can spread quite a bit horizontally across the landscape. And because of those high and low periods, the province at Fairford River, where the Lake Manitoba drains, has a control structure. And starting around the same time the carp were becoming an issue in the early 60s, started managing water levels to try and stabilize those levels. And they've been fairly successful up until the last decade or two, when if there's just way too much water, they can't let it out fast enough. And if there's not enough water, they can't manufacture it. So if we go through a real wet or real dry periods, there's not much they can do above, but the intervening time, they've been pretty successful at stabilizing water levels. That may be okay for the lake, but for the coastal wetlands around the lake, if anybody knows, we talk about the wet-dry cycle in prairie wetlands. Fluctuating water levels is what you need to maintain the productivity and make for a dynamic plant community in prairie wetlands, and that wasn't happening anymore. The other concern we have is the agriculture to the south of the marsh is very intensive, and we have some graduate students. We are just finishing up their projects, and we're looking at the nutrient loading into the marsh, and we think that's contributing to some of the algal blooms that we're seeing in the marsh as well. So those are two other factors that we think are pretty important.
And so I've received a couple questions with a similar theme, Dale, asking about the commercial market for carp. And I think you get into that in a little bit, unless you want to give a little teaser on that.
No, you know what? I'm going to hold off on that one because I do have a slide of harvesting carp at Delta, and we'll talk a little bit more about how you can make some money with a very low value fish.
Great. Great. So I think we'll move on. We've got a couple other questions we'll maybe save for later, but first we have a quick poll question that Sean is going to put up for us. So we want to know your history with Delta Marsh. If you've been there, yes or not for a while, or not yet.
A fair number of people have been to the marsh.
Yeah.
That's good.
Great. All right. I think we'll keep moving. Let's continue with your presentation, Dale.
Okay, I still see the poll, so I'm just going to close that. Okay, and try and get control again. Good, or as everybody, oh, there comes the poll again. Try and close that. Everybody can see the next screen, I hope. Cynthia, you can see it okay?
Yes.
Good. Okay, so as I mentioned, carp have been introduced around the world, and you know, if they were kept as an aquaculture species in ponds and fed in clean water, that would be fine. But unfortunately, as the case in many invasive species, they were either intentionally or accidentally released once they arrived, and they are an issue wherever they are around the world. And there's huge programs in North America. Australia has a huge effort to try and minimize the impacts of this invasive fish species in their programs. And consequently, there's a whole range of techniques and methods that are either been explored or being looked into try. And we're never going to get rid of them, but we can at least try and minimize their impacts. And they range from, well, actually in the first case, poisons. If you've got a small enough system and you can treat the entire system, you may be able to actually get rid of them. And that's using rotenone, which is a pesticide. It kills all fish. So you would treat, wait for a period of time, and then restock with the with whatever fish that you want to have in the system. Exclusion barriers, I talked about the electric barriers that they have in the Chicago shipping canal to prevent the Asian carp from getting into the Great Lakes. Minnesota's been exploring acoustic and bubble screens and metal fences and screens, and I'll talk more about that because that's what we're using at Delta. In Australia, they're using one of the unique abilities of common carp. Common carp are great jumpers, if anybody's ever seen that. But none of the native fish in Australia jump. So they create these barriers, and the carp try and jump over them. They end up jumping over the barrier onto a conveyor belt into a truck and get hauled away. So that's using a unique aspect of carp biology that the native fish community in Australia doesn't have. If you've got habitat management, if you can manage water levels, you can draw that down during the summer when they're breeding and spawning to try and kill the eggs, or you can draw it down in the winter time and freeze them out. You can try harvest management, harvest as many as you can. There's certain pathogens, for example, koi herpes virus. All fish, interestingly, get herpes. And koi is the Japanese name for carp. And carp, or koi, I should say, are the decorative carp you find in fountains and ponds, those nice orange and white and black fish that are swimming around. Those are just carp that have been bred for those fancy colors. Unfortunately, there's a disease in the koi trade, and that's spilled out into the wild, which has caused problems for massive carp die-offs in some locations. We know it did show up at Lake Manitoba around 2008, did kill part of the population, but by no means did it really seem to do much harm to the overall population of carp. And Australia is doing other things. They're looking at genetic manipulation. They're looking at immunocontraception as well. So there's a whole range of approaches that you can use to try and reduce the number of large carp that are present in an ecosystem. At Delta, I'm losing my screen here again. They were so concerned about carp back in the early 1960s that there were some low-head dams that were already present on the channels connecting the marsh with the lake. This is over at Clandeboye in the far east side. What they did there was they put up this pipe frame, and you can see on the left side of the screen, there's a chain link fence there. And they used this chain link fence to prevent carp from getting in the marsh. They also did some harvest around the structures as well. So this again uses the biology of carp, they're wintering out in Lake Manitoba, which would be off to the right, and then in the spring they're trying to migrate into the marsh, and that chain link fence would prevent them from getting into the marsh. Unfortunately, this is not a selective means of controlling carp. It would restrict all large fish from getting into Delta Marsh. So they used the chain link fence for a few years in the beginning, 64, 65 to about 66, 67. Unfortunately, chain link fence is like a net, and it collected all the litter that was coming through the channel. And in many cases, it acted like a dam, holding the water back as well. So it took a lot of time and effort to keep cleaning the screen. So eventually in the late 60s, they abandoned the chain link fence and went to this slanted pole type structure. It has openings of about 2 inches between the pipes here, and the waves can wash the litter up on top of the screen and go underneath, or the waves can simply go over top. So it still allows water to move through the structure. But again, it was restricting access by all large fish from Delta Marsh. So it was put in the late 60s sometime. And then the late 80s or the early 80s, you can see on the right-hand image, it had pretty much fallen into considerable disrepair. Carp fishermen had started to take it apart, modify it to start harvesting carp at the structure. And I guess for whatever reason, people lost interest in it, and the dams were starting to deteriorate. Everything was pulled out in 1982, and from 1982 on, there was free flow of water between the marsh and the lake, and free passage of all fish species between the marsh and the lake as well. So starting in the early 80s, everything was moving back and forth, including the carp, and the marsh continued to deteriorate through the 90s and the 2000s. There was a lot of concern about what was going on at Delta. And again, it was the stakeholders, it was the hunting community who started to really, be concerned about what was going on at Delta. Jim Richardson, for example, held a meeting at his lodge in 1998. These are Manitoba, the image on the left, these are Manitoba directors, some DU staff, as well as some provincial staff, including the Premier of the province, Gary Filman, in the middle in the brown. Jim had everybody there to raise awareness, to show the provincial folks the concerns about what was going on at Delta. There was interest in the media. We were trying to gain more attention of Delta, raise the awareness among the general public and everybody else. And also during this time through the 90s and the 2000s, we were doing a lot of research, really documenting the changes that were taking place in the marsh, including the algal blooms you see, the young lady on the right, scooping up there, but also doing a lot more research on the fish community, because we knew that was important. We know that carp were important. In some of our gillnet surveys, we actually did the very first large fish surveys in the marsh and found that carp made up about half the biomass of the fish in the marsh. So we knew they were there. We knew that the earlier approach was successful. There was improvements in the marsh when they were keeping carp out. But how do we do this without trying to minimize the impact on the other fish communities, the other fish species that are actually using the marsh as well? Because we know Delta is important to many of those other fish as well. So this all came to a head in the mid-2000s, 2009 in particular, with the Restoring the Tradition project. And that was to try and restore Delta Marsh as its preeminence as a waterfowl staging marsh. So again, coming back to the fish community, we know we're trying to benefit the waterfowl that use the marsh, but it serves, it serves for the plants, the animals, the invertebrates. It's habitat for all the other life that use a wetland, including the fish that migrate back and forth between the marsh and the lake. But how can we benefit waterfowl and try and minimize the impact on the other 30 species by restricting one particular species, the common carp? And there's a number of things in their biology that we could use to our advantage. There was some earlier research at Delta that showed they tend to be a late arriving species. And we also know that they can get fairly large compared to many of the other fish species in the marsh. So maybe we don't have to, and we won't be able to keep them all out, but maybe if we can keep enough of the really big ones out, we can see a sizable improvement in the marsh. So to start things off, in 2009 and to 2012, we did some research at the Delta Channel. We wanted to get a better handle on the timing of fish passage into the marsh, and we used the bridge there and the culverts. We could put hoop nets over those and monitor. This is the Delta Channel on the right here, and you can see in the background is Lake Manitoba still frozen over, but the fish are already starting to move into the marsh at this time. And we were also interested in the size structure. How big an opening can we work with to allow as many native fish species through and still keep the largest, most destructive carp out of the marsh? And Carly there is showing one of the screens that we tested. We looked at 50, 60, 70, and 80 millimeter openings between those jail bars on these screens. So based on that information, as well as some fish surveys we did in Delta Marsh to again look at species composition, seasonal abundance, size structure, we came up with some recommendations. 70 millimeters between the openings we thought was the best compromise between keeping out the largest carp, which make up a sizable proportion of the carp population in the lake. We don't put the screens in right away. These are temporary screens. We leave the screens out for 25 days after ice is off the channels, and then we drop the screens because that's when most of the carp, generally in most years, tend to start migrating into the marsh. And then we pull the screens out at the 1st of September. They only need to be there really when the carp are actively trying to get into the marsh. The rest of the year, they're not as interested, or they're trying to go back out to the lake where they're going to start getting ready to overwinter. So these were our initial recommendations. Been some changes to those. We're still going with the 70 millimeter screens. Now, deployment of the screens is now based on a temperature model. We have a cell phone enabled water temperature probe that we monitor temperatures in the channel in real time and use 9 degrees Celsius as our cutoff in terms of when we actually drop the screens, because that's when carp tend to be more active and start really moving into the marsh. Some are moving before. We're not going to keep them all out, but we are going to keep most of the carp, especially the large carp, out of the marsh. And now we actually lift the screens the 1st of August, and we might even be able to push that a little earlier. So based on those recommendations and a successful fundraising campaign to raise the money to build the structures, and that money came from private donors, it came from the provincial government, from Ducks Unlimited, NACA, big supporters of the project. So bringing all that money together, we actually constructed or modified 7 existing structures or made new structures around the marsh at those connections between the lake and the marsh to restrict a large common carp from getting into the marsh. Over on the far east side at Clandeboye Bay, we didn't build a new structure right at the edge of the lake where that original dam and chain link fence had been put. They ran into issues with ice. There's also a substantial flow through that small channel. Over on this side of the marsh, I think it's about 75 to 80% of the flow in the entire East Marsh comes just through Clandeboye Channel. So to prevent issues with building a structure right at the edge of the lake there, we built 4 structures around Clandeboye Bay. Fish Creek modified the existing culvert that was already there, put in new structures at Waterhen and Crooked Creek, and then put in just a culvert at Robertson Creek, which was an old paleo channel which had been pretty much filled in with cattail. Over at Delta Channel, we modified the existing bridge that was already there. And then over in the far west side at Cram and Deep Creek, new sheet pile structures were put in there. So the winter of 2012, 2013, we went in, we have to do the construction in the winter, of course, to get heavy equipment in here. Here the channel has been dammed and drained, and the heavy equipment has come in and is pounding in the sheet pile. This is what it looks like when the sheet pile has already been pounded in, and the welders are here welding in the guides on either side of the opening, and this will be where the screens are dropped in these guides. You can see the walkway that goes across the top of the structure is being put in, as well as the monorail across the top that holds the winch system that we use to lift the screens up and drop them in and lift them up when we want to clean them, for example, if they get some vegetation on them. So this is what the structures look like when they're finished. This is the one over at Waterhen Creek, and you can see here's Rick Andrews walking across. The screens are in position in the Waterhen Creek structure. So what happens when we put those structures in the springtime? Well, initially you don't see very much, but then later, probably around this time of year, if you're ever there during a south wind, that warm marsh water is now going out to Lake Manitoba. This is what you're going to see at those channels. This is Deep Creek over on the far west side. This is one of the smallest channels. It's located fairly close to the lake. And what you're seeing there, all of that is common carp that are piled up at the screens. These would be the large individuals trying to get into the marsh, being held up by the screens. And it can be a pretty phenomenal sight. This is what I think when they mentioned you could walk across the backs of the carp, this is probably what it looked like back in the 60s at times. And you can see pretty high numbers of carp there. And remember, these are bottom fish. They want to be on the bottom. So essentially what you're seeing is fish stacked on fish, stacked on fish. The water column's about this is a shallow, one of the shallowest channels. It's about 1 meter deep. So it's 1 meter deep of fish from one side of the channel across to the other. So what we've done is we put a physical barrier here in terms of the screens, but now our concern is a biological barrier here that could be restricting other fish species from getting in. You can imagine if you're a small fish trying to swim through that, you're going to have a tough time. So other people have seen these videos as well, including commercial fishermen who fish out on Lake Manitoba. There is a small commercial fishery for common carp, and they use a variety of approaches to harvest carp, beach seining and things. But when they see these videos, initially there was you weren't allowed to fish at the structures, but the provinces now allow carp fishermen to actually fish at the structures. So what they do is they drag seine nets from one side of the channel to the other, and you can harvest a fair number of fish fairly quickly just by dragging the seines across in front of the structure. This is actually at Fish Creek. It's one of the smaller ones. They do that use a fairly small net like this because these guys tried to use a larger net, and the net pulled them into the channel. There was just so much biomass and so many fish in the net. And unfortunately, right now, it's still pretty much a manual job. Hopefully, as this fishery expands and as the need for more fish protein increases in the world, this will become more mechanized and become a much more efficient fishery to harvest the carp and remove some of that biomass that's congregating in front of the screens, and then minimizing, hopefully, the impact on other late arriving fish species that are trying to get into the marsh. So again, we're at another spot where we can ask some questions. Cynthia.
Thanks, Dale. So one of the earlier questions was about the commercial market, but can you explain a little bit more about what kind of food products are made? I mean, they're a low value product, but what do they make with them?
Actually, in the springtime, carp are more valuable, particularly the females, because of the roe that's removed from the female fish. They actually make Greek and Turkish dishes. I believe the name is tarama salata. They blend that with cream and other spices and such, and they make a fish or cracker dip, which has got kind of a fishy flavor to it. It's a Greek and Turkish dish. The flesh itself is, for the most part, I believe it's exported either to Asia or the Middle East, or Eastern Europe, where it's processed into gefilte fish and other types of fish products. North America, it really hasn't taken on. It's got a very dark coloration to the fish, and there's a lot of bones in it as well. I know recreational fishers like to fish for common carp. They do give you quite a fight, but I'm hoping that if we can manage our regular recreational fish species more like pike and walleye properly, we don't have to do like the Europeans do and resort to only fishing for common carp.
Great. Any other questions? We have a couple minutes.
Dale, can you hear me?
Yep.
I've been up on the Fish Creek and then further up in Clandeboye and seen the destruction of the activity of the carp, that they mine away the edges and go around the structures. And have you been able to solve that?
Yeah, that was a concern when the structures were first built in 2013, that very first year. They didn't put riprap on the marsh side, and we weren't thinking properly that, okay, some of the large carp are still going to get in, and some years more than other years. And in fact, as you say, they erode the shoreline to such an extent. If you'd have given them several decades, they might have actually dug a channel right around the structure. So what we've done is, I think after in the flood in 2014, we lost some of the dikes around some of the structures. So I think it was in 2015, they put more riprap, more rock around the structures themselves in the channels, as well as the dikes around the structures as well, to try and prevent that. And since then, I don't think we've seen as much evidence of erosion by carp around the structures or around the dikes either.
Thank you.
Great.
But they
All
are
right,
very aggressive.
Yeah. I think we've got another poll question. Sean, do you have that ready for us? So we'll see how long you think it took to build the Delta Marsh structures.
I showed some dates on those screens. So we'll see if they were watching the dates on those screens.
Great.
I presume you actually know the answer.
We were there watching.
All right, it looks like most everyone has voted, so I think we'll continue. Great engagement, everyone, and keep coming with the questions. Yeah. We'll have more time at the end. So Dale,
you're not going to give me the answer, Cynthia, or should I give him the answer?
Oh yes, sorry. Yes, give the answer.
It was 3 months. Yep, from the end of December through the middle of March. So January, February, March, yeah, middle of December to middle of March, 3 months to get everything in there, get it all done as quickly as possible before things started to thaw out in the spring. So 3 months from December of 2012 to March of 2013. Okay, I'm going to hopefully continue on here. So with the construction of the structures, so 2013 was the first year of operation of the structures in terms of our carp exclusion. So in Canada, fish habitat is a federal government responsibility through Fisheries and Oceans Canada. And any interference or with fish migration, for example, requires federal permit. And so in order to interfere with fish migration, which is what our structures actually are doing, even though we're dealing with an invasive species and they recognize the benefits of that, we still need to convince provincial and federal fisheries of, yes, we're reducing an invasive and minimizing its impacts in the marsh, but we're also minimizing our impacts on the native fish species. So we continue to monitor fish migration. That was the information that we used to guide how we were going to use temperature in terms of timing of screen drop. And then we looked at the community of fish in the marsh using electrofishing and gill nets. And then we also looked at small fish sampling to look at production of fish in the marsh. We wanted to look at the community. We were sampling in the years before carp exclusion started, so from 2009 to 2012, and then 2013 to 2018 for 6 years afterwards, and compare the fish community before and after, and also inside and outside the exclusion zone. And also looked at what was going on with the provincial fisheries data in Lake Manitoba to compare what was happening in Delta Marsh. And that's the analyses we're doing right now as I speak. We're just finalizing that report in terms of our fisheries monitoring. And I'll talk a little bit more about that in a second. And then, of course, we were also interested in the habitat responses. How did the submersed vegetation respond to reducing large carp presence in the marsh? How was the water quality responding? And of course, most importantly for us, how did the waterfowl respond? And we looked at a number of things with waterfowl, looked at migration counts. We also did some work on body condition for ducks. You know, are they getting the food resources? Are they putting on fat, for example, while they're at Delta, the energy they need for fall migration? In terms of the fish, I could show you a lot of graphs that we're just in the process of producing and analyzing and writing up the report. The data that we've done and we've looked at, for the most part, shows us that the fish community in the marsh has not changed significantly before and after and inside and outside. Fish continue to use the marsh, so that's a positive for us. There could be a couple of species, particularly juvenile drum, freshwater drum, that are trying to get into the marsh when the carp are there. They're a late arriving species, and we do see lower numbers post-carp exclusion in the marsh. Unfortunately, the province doesn't have good data on what's happening with them in the lake, so we can't say it's absolutely the screens. It could be happening in the larger system as well. But there might be some indication that, and that probably wouldn't be a big surprise, that some late arriving species may show some reduction in numbers. Just trying to get through that massive carp into the marsh could be a challenge for those species as well. I did mention that We don't drop the screens right away. Many of the native fish species are early migrants. Northern pike, whitesucker, walleye, for example, will come into the marsh before the screens are dropped. We're trying to time it when the massive carp are really arriving, so some carp are coming in early as well. We can't keep them all out, we recognize that, but we're trying to allow as many of the native fish species in the marsh before we drop the screens. Many of the species are narrow enough that they can get through those screens, and many, if there are larger individuals for some of the species, they can get in the marsh before the screens are actually dropped. But one of the concerns we had was, well, if those fish get in and we drop the screens, those large individuals, what happened to them when they're held in the marsh for the summer period? So we did some work on that. We actually sampled fish as they were trying to get out of the marsh. So we put our hoop nets on the other side of the structures and looked at what's called body condition. It's a ratio of the length of a fish to the weight. So if you've got a really long fat fish, that's in good condition. But if you got a really long skinny fish, didn't get enough food, isn't doing really well, you'll see that in this K factor or body condition factor. So we were interested in, do we see evidence of fish in poor condition, large fish in poor condition that have been held in the marsh for the summer, trying to get out of the marsh when we lift the screens in August? Are they in poor condition trying to get out? This is just some example of some of the walleye that we caught. This is early August, just before we actually lifted the screens in 2017 for the summer. This is walleye. These are tag numbers. You can see the little 101, 102, and 103. And just below the pictures, you see the width, the actual width of those fish. So 101 millimeters for 101, 111 for 102, and 112. So these are fish that are way too wide to get through those screens. I mean, some of these fish can squeeze, but they can only squeeze so much. And if they're too hard, the bony structures and stuff, they can't get through. So these are walleye that would have come into the marsh early in April or just before the screens were dropped in 2017, spent the summer in the marsh, and then we captured them as they were trying to leave in early August. These are all master anglers if you were a fisherman in Manitoba. And you can see these walleyes are looking, well, they're all in great condition. Their body condition is just fine. And so these fish are not having any issues being held in the marsh over the summer period. In fact, fish number 101 was caught by a recreational fisher in the winter of 2017. I think it was actually in the winter of 2018. A year later, was caught out in the lake by a recreational fisher and was reported because of the tag, or the Floyd tag that it had. Fish number 102, the middle fish here, we caught that same fish and exactly a year later, coming out of the marsh again. So this fish, number 102, spent the summer in the marsh in 2017, liked it so much, it came back and spent the summer of the marsh in 2018, and again, looked like it was in great condition based on body condition. So this was, again, some more positive news that our structures aren't having a significant negative effect on large fish that are coming early into the marsh, being held in the marsh, and then leaving when we raise the screens late in the summer. So, okay. So what I want to talk mostly about in the last few slides is what happened to the habitat conditions in the marsh and how did the ducks respond to what we're seeing with the large carp exclusion. So this is a photograph of the south end of Waterhen Bay, and this was a shock even to me. Waterhen Bay is one of the very large bays. It's just south of Clandeboye Bay. We expected that the submersed veg response would happen initially in the smaller bays where it's more sheltered from wind and wave action, and it had a chance to establish there. And then over time, as it's producing more seeds and reproductive structures, it would start to creep out from these smaller bays. But here, this is Waterhen Bay, and this is only 4 years after carp exclusion. And you can see the variety of submersed aquatic plants here. The ribbon-looking stuff is giant burrweed, sago pondweed. There's some ceratophyllum in here as well. And what also is amazing to me is this may not look like really clear water, but for Delta Marsh, this is very clear water. You can pretty much almost see the bottom here. And I was very surprised. I didn't think this would happen in the large bays. Again, Waterhen, several kilometers across, a big windswept open bay. And this is at the south end. I didn't think the submersed veg would respond this quickly in the large bays, but it really has. The response has been really to the east side of the East Marsh, and we're starting to see it move a little bit further west with each year. We're fortunate at Delta that because of the concerns about submersed vegetation going way back to the 60s, that 1974, there was a mapping exercise done. So here you can see the bays. I mentioned Chatham and Simpson, East and West Bluebill. There's Waterhen Bay there and Clandeboye. All of these colors are different mixes of submersed aquatic plants that are either present in the ponds or along the shoreline within the marsh. And you can see that there's quite extensive bands along the shorelines throughout these bays, and quite a mix of colors, different mixes of the different plant species present within the marsh. This is 1974. This is 1997. You notice not as quite as many different colors, and definitely a lot more exposed shorelines with a lot of submersed vegetation. And this is 2009, just as we're starting the carp exclusion project. You can see there's not a lot of submersed vegetation, mostly in isolated little corners. It's still present around the Eaton Lodge area and St. Mark's complex. You can still see there was abundant submersed vegetation in 2009, but pretty much not a lot of submersed vegetation present in the marsh, just as we're starting the carp exclusion project. This graph here illustrates the area in hectares in some survey transects. So taking a subsample of those three maps I just showed, this would be 1974, 1997, 2009, and this is what's happened since we've initiated the carp exclusion on the marsh. So you can see 2014, 2016, 17, and 18. Very dramatic increase in the amount of submersed aquatic plants in the marsh. So this is leading to clearer water. We're seeing an increase in the clarity of the water column, more aquatic invertebrates, because this provides more habitat in the water column for the invertebrates that the ducks need to feed on, and it provides more habitat for other small fish species that need protection from larger predators and stuff. And of course, it provides food for the ducks in terms of supporting the invertebrates, but things like canvasbacks that feed on the tubers of sago pondweed, for example. And sago pondweed is one of the species that has been responding to the carp exclusion. We've become a victim, or became a victim of our own success. We generally use these 14-foot fishing boats with a 20-horse outboard motor, and we could motor all around the marsh without any problems. Up until about 2016, it started to become an issue. And you can see here 2017, this is Clare Lake over on the north side, just north of Gadwell Bay. This is Taylor. You can see she's having a few issues here trying to motor through Clare Lake. Mostly what you see here, the red is the flowering heads of water milfoil, Myriophyllum sibericum, a native water milfoil species, and the difficulty she's having. We ended up having to move towards airboats and mud boats, working in some areas on the east side, because our traditional mode of transportation, the outboard motor, just was not effective. It would take hours to motor across some of these bays, just trying to keep the weeds, or keep cleaning the weeds off the propeller. So the submersed vegetation response was very dramatic that we saw out at Delta. And lastly, I'm going to talk about the waterfowl and the fall waterfowl surveys. There's been migration surveys in the fall going back many decades. And so we looked at the trends in those populations. So what we see in the bar chart here is we've grouped the waterfowl surveys into decades: the 1960s, the 1970s, the 80s, the 90s, the 2000s, and then looking at 2013 on to 2018. This is for lesser scaup or bluebills. You can see their numbers were fairly constant through the 60s, 70s, and 80s, but then when the structures were removed in the early 80s, you can see it really dropped off in the 90s, and the 2000s. Scaup numbers were very low in the marsh, and you can see we've seen a dramatic increase, a statistically significant increase in lesser scaup numbers since we initiated the carp exclusion work, back to densities that we've seen since the 60s, 70s, and the 80s. So that's for lesser scaup. Canvasback has been the most dramatic response that we've seen. Again, looking at individual decades, you can see the 60s, 70s, and 80s, and then the really low numbers of canvasbacks through the 90s and the 2000s, and a dramatic increase in canvasback use of the marsh from 2013 on, especially when you compare the 2 decades prior to the carp exclusion work, just how dramatic the increased use. And we believe that's in response to better habitat conditions and better food resources available for canvasbacks in the marsh because of that response by sago pondweed and the tuber production that those plants are providing to the birds. So that's it for a very quick summary. I can talk lots and lots more about different things about Delta Marsh, but I think hopefully that gave you a good summary and overview of the work that we've been doing and the response we've seen at Delta with the Restoring the Tradition project. So Cynthia, I think we can go on to questions.
Awesome. Thank you very much. We wanted to loop back to, we had a couple questions in the chat here.
Sure.
And a couple about cost. So two questions about cost of structures and a question about the annual maintenance.
The cost of the construction of the structures, if I'm correct, it's about $3 million to do the actual initial build. Then there were additional expenses related to the repairs to the dikes, and a lot of other work that had to be done after the initial construction. But the initial construction of the structures was $3 million. But once the structures were constructed, and we're still in discussions with the province on this, but my understanding now is that the province does manage the structures now, and I believe they are taking, either have or will be taking over ownership of the structures and all future maintenance and costs moving forward with the management of the structures.
Great. And we had another question, and you touched on this a bit earlier, Dale, but can you expand a little bit more on the effect on the other 30 or so fish species that you mentioned, and is there ongoing monitoring of that?
No, not right now. We did the 6 years of monitoring that DFO the Fisheries and Oceans required of us, and that's what we're currently doing the analysis of all that data. As I mentioned, right now, the analyses we've seen and looked at, all the species seem to be doing just fine. The only ones I had some concerns, and it does seem to show that drum, freshwater drum, may be negatively impacted by the screens just not being able to get through. And they're not that wide. They could actually get through the screens. I think a large part of it is actually they're a late arriving species at the same time the carp are starting to show up. And I think it's more an impact of trying to get through that roiling biomass of carp at the screens. And you can imagine you trying to swim through that I think that's more the effect of the biomass barrier than the screens themselves. And that's, I think, where we really need to encourage or try and get the province to work more on becoming more effective at that commercial fishery at the screens to minimize or reduce that biomass that's there.
Okay, great. We've got a bit of time for additional questions if anyone wants to unmute yourself and ask a question. I know we're a little bit over our hour, but Carl has asked here, what's the ratio of the above water reeds to the water in the marsh? So have the above water rushes dropped off in the flooding?
The above, oh, you mean the emergent vegetation like the cattail, the Phragmites, yeah. So the flood of 2011, going back even further, I talked about stabilized water levels and the stability and the province managing Lake Manitoba for stabilized water levels. If you look at the emergent plant communities, and again, we're very fortunate in that lots of people have been looking at that over time, you can see a steady, when I first showed up at Delta, it was a little while ago, the marsh was dominated by Phragmites. And what we've seen, and if you look at the maps going from the 1960s through to the early 2000s, it was a Phragmites marsh that was being converted to a hybrid cattail marsh. And the flood of 2011, it was a major negative to the landowners, to the cottage owners. It was very destructive, did a lot of damage, hurt a lot of people around the lake. But unfortunately for them, it was fortunate for the marsh because that's a high water event that really you need to set back the emergent vegetation. So we saw a massive die-off of the hybrid cattail, the Phragmites. If you look at some satellite imagery, for example, in that area, you can see a lot of interspersed flooded dead areas behind the the cattail edge. So there was a lot of shallow flooded areas that were created, a lot of openings that were then created. So it was actually very beneficial to the marsh and to the waterfowl that were using the marsh, particularly the dabbling ducks really responded because a lot of shallow flooded habitat that was now open. But what we've been seeing, of course, now is a slow ingrowth again. Hopefully we'll see some of those other species, some of those species have been responding. It's just how long it's going to take the cattail to kind of take over again. I'm sure we're not going to try, the province is going to try and minimize any opportunity for another one of those big floods. And they're going to spend $500 million building another channel at the north end of the lake to make sure that doesn't happen. So unfortunately for the marsh, we're probably going to come back to, although the province says not say quite stabilized, we're probably going to come back to somewhat more stabilized water levels than we probably like to see on the marsh.
Great. And I think we had a question from Greg Meisner. Greg, do you want to unmute yourself and ask your question?
Sure. Can you hear me?
Yep.
Yep.
Dale, those numbers of ducks in the marsh, were those reflective of the number of birds using the marsh, or were they in part reflective of the populations of those birds, or both?
Those would be just the birds using the marsh, and we don't know how long they're there. We think they're there longer now because, of course, resources are better for them. And part of the work we were doing is we were doing some collections. So we're looking at actual body condition. I talked about the long, skinny fish in terms of being held in the marsh. We're looking at some of the waterfowl to get a better idea of, you know, are they getting the resources? Are they actually putting on fat? And there's measures in the blood system that we can use to see if they're actually using up fat or depositing fat. And so we've been doing some collections and looking at that. I don't have the results from that. That's some of the other folks that are working with us on the project who have been collecting that information. But so those are surveys that are flown in the morning. So that would be indicative of just the birds that are there at that particular time. And if we see lots of birds there and they seem to be there for long periods of time, we think they're getting the resources they need, feeding, putting on the fat, and then of course at some point each species moves through at a different time and they would continue on with their migration. Did I answer your question?
You did. Thank you, Dale. Very nice presentation.
Oh, thank you.
Great. Well, we've had a few people who've had to drop off for other meetings. We had one question though I did want to acknowledge, which was what does our crystal ball say about a hunting season for US participants? And all I can say is that I hope to be back at Delta Marsh this fall. I live in the US, so that might, I'm hoping that happens. But I do not have a crystal ball. I wish I did.
Yeah, the COVID situation, it's going to be difficult to know what's going to happen.
Yeah, yeah. So thank you so much, Dale. We saw from our poll earlier, I think 19 of the folks who were on with us tonight had been at the marsh, and I was fortunate enough to spend some time there last year with some of the people who are on the call with us tonight. So I really do appreciate your coming on and telling us about all the effort that's gone into revitalizing this marsh. It's been an epic amount of work. And I just want to reiterate that this is the type of impact we can have on the ground when all the pieces come together from donors across North America who've invested in this and whose philanthropy has enabled us to access the funding needed to take on these challenges. So I think we did our last poll. So thank you very much to all of you who attended tonight. We will be having another virtual event and we'll make sure that you get the information about that. And thank you again for sharing part of your very busy day with us. I know Zoom calls and Teams meetings have become the norm, and I really look forward to the day when I can see all of you in person again. So thank you again for all you do for wetland conservation, and have a fabulous evening, and thanks for joining.
Thank you very much, everybody.
Thank you, Cynthia, and thank you, Dave.
Thank you.
Appreciate it.